All right, this is code that I developed for my content theory, and in this code, I am not developing the front-end application that shows interaction between a system and the user input. It was something that I wanted to do, but given the circumstances of the past week, I've had to focus primarily on this. So my content theory is focused on storytelling, emotion-driven storytelling, and I've positioned some ideas in my content theory that necessitate the question, well, how does this work? So this code focuses on some analysis that proves out how the back end of the system will work. And primarily what we're seeing here is, one, how we create a user model using input that they provide, emotional input or emotional words or content they provide in what I've called a get to know session. The get to know session is the initial session where the user and the system interact. I also show how we create a model of stories. I show how we model both the user model and a story model in a feature space, and how we might then use that to perform a user story match. So primary thing here, I'm importing spaCy, which is an open source library where I can get a module, an already pre-trained word embeddings module with that has been trained on, I believe, a Google data set with over 1 million words, and which maps to over 700,000 pre-trained vectors for different words, based on a set of blogs that have been extracted and trained on for word embeddings. So here's the first step. We create the user model, and we're going to use this spaCy model in a minute. And this is primarily done within the function. So these are the questions that the GTK session is asking. Very quick, very brief as example. If you catch me on any day, I typically be blank. I typically admire people who are blank. Right now, I'm feeling blank. And these are areas, these blanks, we want the user to fill them in. And these questions, if you look at them, they're actually representative of three things. This one, if you catch me any day, I typically be, this is really trying to get a sense of the user's constant emotion space or default emotion state. I typically admire people who are, and this is now capturing the user's emotional aspirations. And right now I'm feeling blank. This is capturing here and now. This is very volatile. So I'm trying to model all three of these within the user for the user. So here's a function where I'm saying, okay, create the user model using the user response variables that we capture from here. We're processing that. We're processing the user input using this NLP variable that I pulled in, which has a spaCy pre-trained module here, and also that's trained on top of a neural network. I don't have the fine-grained details on that, but it's a neural network that's working under that. And then we have the ability to capture one user vector, and so it'll take the composite of all the three sentences and create one user vector, and so we'll see that shortly. And that's meant to represent the user's model and the user's position in a numeric feature space. So here's some test user responses. I'm testing three users here, user A, B, and C. It says, if you catch me on any day, I typically be critical. This is the first user. I admire people who are blissful. Right now, I am feeling sad. Look at user C. If you catch me on any day, I typically be relaxed. I admire people who are optimistic. Right now, I'm feeling relaxed. So different users, you want to see how they how they we want to see what they look like when they're modeled and put in a feature space. Okay, so here we're simply just running this. Here we were putting their inputs into a one variable, one unique one for each user. Here we're defining that function, and so here what we're doing is running the function we define on each of these variables that are storing their inputs. And so now I say print user A vector, print user B, print user C vector. So all of these here, this is user A vector. It's a vector of 300 dimensions. All of these would be 300 dimensions. A 300-dimensional, essentially if you can model them in a 300-dimensional space, all of this is capturing information about who the user is, typically who the user aspires to be, and who the user is now. And this is all in terms of emotion context. So all of these numbers are word embeddings that take the composite of these three inputs from the user. Okay, so we have that, and this is user vector B, just showing all the vectors here, seeing what it looks like. That's user C. And I just said, okay, let's do something. Like, let's look at how similar these vectors are. And I just say, is test user vector A equal to test user vector C? And I'm just seeing false here. So which is really interesting because the input sentences are pretty similar for each user. When I say they're similar, they're using primarily similar words. Right now, I'm feeling. Typically, if you find me on a regular day, I typically be blank, right? But the differences come in the type of words that the user puts into that feedback. But you can see here, none of these numbers are actually the same. So that's telling me that word embeddings is actually taking the different words that the users are putting into the system and is mapping them differently based on contextual or semantic information, which is a positive. Going from there, I do just a test here. That spacing module that I did has a default similarity metric, and I just want to say, okay, based on what we're seeing here, it looks like nothing's equal. How similar is test user A and test user B? How similar are test user C and B? How similar are test user C and A? And they are different, but they're typically the same, close to the same, almost one, which is fair, right? The sentences were similar to each other with some differences in the emotion words. But let's imagine, for example, this is just representing each user's first interaction with the system. So it's understandable that the system doesn't know the users very well, and so they all look the same. But imagine, right, with historical or with continuous interaction with the storytelling system and continuous sessions where we're learning about the user, and if we're even to take it away from just capturing emotion information to like user demographics or location, like the things that are typically used on Netflix and all of that, this similarity score will decrease a lot, right? Because the users will now start to look different. But this is just the start of things. So the fact that they're similar, it's okay with me. Now I just want to see visualize user vectors. I want to see what these visual users look like in a feature space, right? So I have their user models. They're arrays of 300 dimensions. But to visualize it, I need to kind of take this down to 2 dimensions. It's easy for the human eye to see 2 dimensions. So what I do is a principal component analysis here. It's a data science method where you reduce the dimensionality of your data. So I'm reducing from 300 to 2. Dramatic, yes, but we just want to see what this looks like. And so I run that PCA and I create new vectors for each user. So now these 2 numbers represent user A, this numbers represent user B, this numbers represent user C. And then I typically just want to visualize them. So here we go. Here's user A, the critical user. Here's user B, the optimistic user. Here is user C, the relaxed user. So we're seeing them come out in different spaces. Okay, that's great. So we've modeled the users. Now let's map the stories into a feature space. In my content theory, I said that I want to take each story and I want to take each story and splice it into the different characters and capture emotion context for each characters. I actually started that journey, and maybe I can go into my terminal here a little bit. I started that journey and I found a Stanford pipeline that can actually analyze different books. So here, this has actual novels. So Oliver Twist, or Emily Bronte's Wuthering Heights, Oliver Twist by Charles Dickens. And you run it through that pipeline and you can actually get some very interesting information. So if I go to, let's say, okay, I ran it on Where's the tokens? Okay, tokens here. I ran it on Oliver Twist by Charles Dickens, and what it does is it gives you a couple of data files. First is a token file, so let's go ahead and open up the tokens file for Oliver Twist. And what it does is it actually took every single sentence in this novel and it gives you the parts of speech, and it's analyzed it based on, like, okay, for example, here's paragraph ID number. Actually, let's go into where the story actually starts, because this is all like table of content information, etc. This is all table of contents. Okay, so here we go. Now we're into the story. And it takes each sentence in the story and just splices it out and says, what is the role of each word in this story? Is this word a verb? Is this word an adjective? And if it's an adjective, what's it describing? And if it's a verb, who's the actor of that verb? Who's the agent and who's the patient? So it has this information in here. Very, very, very detailed. And I wanted to analyze this further to be able to splice it out by characters. But again, running out of time, I couldn't go quite into depth into that, which is my idea. So I said to what's easily accessible. And what was easily accessible was to just take the entire content of the story and again map it out using word embeddings, the same way I did with users. My 3 stories here are not novels. They are plot summaries that I captured from Wikipedia. It's a little simpler to work with. Plot summaries of movies. And and the movies I selected are The Notebook, If Beale Street Could Talk, and Ocean's 11. So if we want to even take a look at that, nothing too special here. I saved this plot summaries on my Gmail drive, and here's The Notebook, a quick 1-pager on the movie The Notebook. Oh, I was going to do about 8 movies, but I just kind of simplified. But here's If Beale Street Could Talk, just 1-pager about each of these. Okay, now if I go back to my code, oh, I closed it out by accident. Let's open that up again. All right, so going back to where we were, I take my stories, I run a story model using the same way. I create a story model. I write a function where I'm creating a story model. And this, again, we're using that NLP variable that has the spacing module for the pre-trained word embeddings that have been trained using neural networks. And we're pulling out a composite vector, 1 vector for each of these stories. Just to move a little faster on my code here, I pulled a composite vector, same thing as I did with the user models. I pulled I ran PCA on each of these vectors because, again, we got a 300 dimension, a vector or an array of 300 dimensions. And then I also visualize those. So these are my stories, right? The Notebook, Ocean's 11, Beale Street, If Beale Street Could Talk. And I said, okay, great. Now can I place these two, the user model and story models, in the same feature space? And essentially you can, just with some Python coding. And so here, this is where I am, or if it's helpful, I place all the novels really in the same bucket, in the same variable as the users. Of course, splicing out which of the values in that variable are users and which of the values in that variable are stories. And then I take all of that and I module it here. Of course, I could have done a little more fancy visualization where stories are 1 color and user are 1 color. But the point is, I'm showing you how we can take emotion content, textual emotion content from users and model them, textual story content like the movie summaries and model them, and then place all of that textual information represented in a numeric space and see how users compare. Now, with word embeddings, when you use word embeddings to place text content in a visual space, now your option are now distance metrics, so Euclidean distance or cosine distance with word embeddings. There's certainly opportunity to define more complex roles that allow for more elegant storytelling. But for now, I mean, this is what we're seeing. For example, if this is a working model, and the user A comes to the system and places his or her emotion content, this system is going to recommend, or is going to display, Ocean's 11. Same for user B, because Beale Street is close to this user, and we can literally take this position to be like, this to represent the user's emotional space. And so, given this user's emotional space, Beale Street is the right movie for him or her. And that is my code for this content theory. Yep, certainly a project I would like to take on more, but here's where I am for now. Thank you.